Hi, this is Mrs. Stephenson. Some of you are having some trouble with one of the stoichiometry problems, and I just want to talk about it a little bit. I don't really want to do that problem for you. I want to do a related problem. The problem you have concerns hydrogen gas reacting with nitrogen gas to make ammonia. That's kind of a difficult problem. I want to talk about a little bit simpler one, and then if you see this one, maybe you'll figure out how to do the hydrogen and nitrogen problem. So I want to make table salt. Let me show you the formula for table salt. It's NaCl. When you get to the ionic bond section, you'll see why you just have one atom of sodium reacting with one atom of chlorine to make table salt. But until then, you're just going to have to accept that this is the formula. Now, we're going to need some sodium to make that, and sodium comes as a metal, and as an element, it's just Na. Okay? We're going to react that with chlorine gas, and chlorine gas has the formula Cl2, and when you react those together, you get a beautiful explosion, and you end up with table salt. Now, what I want to talk about for just a second, even though it's a little bit off topic, is why this Cl has a subscript 2 and why the sodium doesn't, and how you're going to know whether or not to put subscripts on. So for this class, because it's beginning chemistry, the only subscript you have to worry about is whether or not you have a 2. Okay? Any element that comes as a pair is called a diatomic element, and there's only 7 of them that you have to learn. It's a really nice little mnemonic that'll help you with that. So if we look here at the periodic table, you can see that there are 7 of these. They start with the element 7, which is nitrogen, and they actually make a 7 on the periodic table. So the first diatomic elements are nitrogen, which always appears as N2, oxygen, O2, fluorine, F2, chlorine, Cl2, bromine, Br2, and iodine, I2. Now, if you count, that's only 6 elements, and we said that there were 7. To get to the 7th, you have to go up to hydrogen. That means that these are the 7 up elements. And if you remember 7 up, they start with element 7, they make a 7 on the periodic table, then you go up to hydrogen. You'll remember all of the diatomic elements. If your element, the one you're worried about, is not on this list, you don't have to worry about a subscript unless we tell you there is one, okay? So because sodium's not on this list, it does not have a subscript, but chlorine is on the list, so we use 2 as its subscript, okay? It's one of the 7 up elements. Now, this is a fairly good description of the qualitative reaction between sodium and chlorine gas to make sodium chloride. I haven't written the state of matter. Sometimes you see that, a little solid here, a little gas here, a little solid here. Because I'm not too concerned about that, we're worried more about the stoichiometry. So I just want to point out that qualitatively this is okay, but quantitatively it stinks. And here's why. I've actually managed, if this is my reaction, to destroy a chlorine atom, and that's a big no-no. So we start off with 2 chlorine atoms. That's a chlorine bonded with another chlorine. Okay, so there's 2 of them there. But I end up with only 1. So I've destroyed a chlorine atom, which is not allowed. The sodium doesn't give me that problem. I start off with 1 sodium, I end up with 1 sodium, no problems there. So I need to balance this equation, make sure I'm not creating or destroying matter. Okay, so since I start with 2 chlorine atoms here, I'm going to put a 2 in front of this sodium chloride particle. And then I have 2 sodiums and 2 chlorines. I just have 2 particles of sodium chloride. Okay, that's allowed. And it makes the chlorines balance out. I've got 2 chlorine atoms here. I've got 2 chlorine atoms here. The sodiums are messed up though now, because I start off with 1 sodium atom, I end up with 2. I'm going to put a 2 in front here. So I'm going to start off with 2 sodium atoms, I end up with 2 sodium atoms. I start off with 2 chlorine atoms, I end up with 2 chlorine atoms, and I've got a balanced equation. You can only work with a balanced equation for stoichiometry problems. Now, unfortunately, I want to know something about the number of grams, because if I'm working in the lab, I will be measuring things out in grams. So let's suppose that I have 35 grams of chlorine gas, okay? And I have as much sodium as I need, and I want to know how many grams I can make of sodium chloride. You can see that's very much like the problem you have to solve. So the first thing I have to do is I have to change this equation into one that talks about grams. And I'm going to do that using the periodic table. Because on the periodic table, under every element, you can see a number that has a whole bunch of decimal places. Boy, it's really hard to see on this. Let's see if I can get it closer. For example, in carbon, if I can get this on the screen, underneath the carbon, you see that 12.01 here. I can't do this very well. Okay, here we go. 12.01115. That's the atomic mass. For carbon, I'm going to put this up here, which is not really part of our problem. For carbon, let me write where you can see it. For carbon, there are 12.011 grams in every mole. Okay? Now, I'm just going to call that 12 because we're all friends here and I can't measure anything that carefully anyway. If there are 12 grams per mole, that means if I measured out 12 grams of carbon, I would know that I'd have 1 mole, okay? And I don't think it needs to be said, but let me just be sure you understand this. This could be 2 atoms of sodium, or it could be 2 moles of sodium. The reason why is I can always multiply everything by Avogadro's number, and as long as I multiply everything by Avogadro's number, I have this all translated into moles, okay? That's no more complicated than saying I could have 2 dozen atoms of sodium plus 1 dozen atoms of chlorine gas gives me 2 dozen atoms of sodium chloride. And remember that a mole is really just like a dozen on steroids. It's a huge number. It's not 12. It's 6.02 times 10 to the 23rd. Okay, so if I know how many moles I have of each of these things, and I know how many grams there are in every mole, I can convert this to an equation about grams. So let's look at some atomic masses for each of these elements. Okay? So for sodium, let me get rid of this for a second. For sodium, if you look up on the periodic table, you will see that sodium is 22.9898 grams per mole. Now, I'm going to call that 23. So it's about 23 grams per mole. Notice that I have 2 moles of sodium. So I just need to multiply this by 2 because each mole has 23 grams. So I have 23 plus 23. So instead of 2 moles, I have 46 grams of sodium. Okay, in this equation. I need 46 grams to make 2 moles of sodium. Okay, now I'm going to continue doing that with all of these other values. Chlorine, I have these written over to the side that you can't see, is about 35.453 grams per mole. We're going to call that 35 because I'm just rounding. So it's about equal to 35 grams per mole. But remember that we don't have plain old chlorine, we have Cl2. So I need to multiply that by 2 because each of those chlorines have 35 grams per mole. So Cl2 has about 70 grams per mole. And I only have 1 mole of it, so I have 70 grams. I need 70 grams here to make this equation work. Okay? All right. In other words, I need 46 grams of sodium added to 70 grams of chlorine gas to make this reaction go. All right, so let's look at sodium chloride now. We have all the information we need to figure out its molecular weight. So sodium is about 23 grams per mole, and chlorine is about 35 grams per mole. That means that sodium chloride is about 23 plus 35 grams per mole. Just add them up, right? Because you have to account for each of those atoms. And 23 plus 35, what is about 58? So that's 58 grams per mole. Now, I have 2 moles of sodium chloride, so I'm going to be making 2 times 58 grams. So 116 grams of sodium chloride. In other words, I need 46 grams of sodium, 70 grams of chlorine gas to react together, and when I'm done, I will produce 116 grams of sodium chloride. So now I have everything I need to answer a lot of questions. The question that you're concerned about with the nitrogen and the hydrogen gives you a small amount of one of those. So let's take a small amount of this. Let's suppose that I don't have all 70 grams of chlorine gas. I only have 35 grams of chlorine gas. Okay, so if I have 35 grams of chlorine gas, in other words, I have half as much chlorine gas as I needed to make this entire equation go, then I would only produce half as much table salt, right? So instead of producing 116 grams of table salt, I would produce half of that. In other words, I'd produce 58, so this chlorine here, I would produce 58 grams of table salt, right? Because it's all proportional at this stage. We're just talking about ratios. Well, let's suppose that instead of having half as much, I have some awkward amount. Suppose I have 10 grams of chlorine gas, and I have plenty of sodium. Okay, I want to know how much sodium chloride I'd make. Well, now I need to make just a nice proportion. So I usually need 70 grams. I only have 10 grams. Okay, so I'm going to take 10 grams of chlorine gas. I usually need 70 grams of chlorine gas. I don't know how much sodium chloride I'm going to make, but I usually make 116 grams, okay, of sodium chloride. Now I need to solve this ratio for X, and I'll figure out how much sodium chloride I'm going to make. I'm not going to actually do that math for you because that's pretty simple. You just multiply both sides by 116 and you'll get the value for X. Now, if you don't understand something in what I've just done, let me know. Email me through the class and I will answer your questions. Otherwise, I think you're good to go with the problem that everybody's having difficulty with. Remember that first you want to describe the reaction with an unbalanced equation. Then you want to balance the equation, and then you want to convert it into an equation about grams, and then you just want to set up a ratio. Okay? Thanks for paying attention to this very long video. Remember, if you have any questions, email me through the class.